Alright, this is exam 3 for Physics 101 from fall 2012. This chapter covered chapters 5 through 8. Alright, which of the following is an example of a non-conservative force? Friction is the only non-conservative force that doesn't conserve energy. Gravity and magnetism are both field forces, so those are both conservative forces. If the mass and velocity of the ball are tripled, the kinetic energy is increased by what factor? Kinetic energy is 1/2 mv squared. If I triple my mass and triple my velocity, that's 3 times 9, which equals 27. So the answer is D. Rock is thrown straight up with an initial velocity of 15 meters per second. Ignore the energy loss to air friction. How high will the rock rise? Goes up, comes back down. Here it only has kinetic energy. Here it only has potential energy. So you say kinetic equals potential. Cancel my m's. I'm solving for h. So 1/2 of v squared, that's 15, divided by 15 squared, divided by 9.8. That's 11.5 meters. 11.5 meters. The unit of work, Joule, is dimensionally same as which of these? Alright, remember the unit of work is force times displacement, so it's the same as a Newton times a meter. A Newton meter. Hooke's law spring is compressed at 12 centimeters from the equilibrium. Potential energy stored is 72 joules. What is the spring constant? Well, potential energy is 1/2 kx squared. That's 72 times x, which is 0.12 meters. And that's squared. Now if I solve for k, let's see, that's 144 over 0.12 squared. 10,000. So the answer is A. Which of the following is a form of energy associated with object's motion? That would be kinetic, D, for number 6. 75 kilogram swimmer dives horizontally off a 500 kilogram raft. Alright, so it's raft, swimmer on it. That's the initial situation. Both of them have a velocity of 0, so the initial momentum equals 0. Afterwards, my swimmer jumps off of the raft in this direction, and so the raft is going to go in that direction. So this is VF for the raft, VF for the swimmer. Alright, so I say my initial momentum, this has some final momentum, say my initial equals my final, that is 0, equals the mass of the raft, 500 kilograms, times the velocity of the raft, plus the mass of the swimmer, which is 75 kilograms, times the velocity of the swimmer, which is 4 meters per second. And then if I solve for VR, it's going to come out negative, but I'm just looking for the speed. And if I solve for VR, I find that it's 0.6 meters per second, negative 0.6. Just so you see the algebra, this is 70. Let's see, I'll put it over here. I say negative 75 times 4, subtract that from both sides, divided by 500, equals 0.6, negative 0.6. In a system with two moving objects, when a collision occurs between the objects, total kinetic energy is not always conserved. In fact, most collisions, the energy isn't conserved. It's only collisions between objects where only conservative forces, such as field forces, are applied. Total momentum is always conserved. It doesn't matter what kind of collision it is. This isn't true, and that's not true. So B is the right answer. If the momentum of an object is tripled, kinetic energy will change by what factor? Assume the mass of the object remains the same. Momentum is mass times velocity. So if this is tripled, that means that the velocity is tripled. So what happens to the kinetic energy? That's 1/2 mv squared. If I triple v, that gives me a factor of 9 for the kinetic energy. System of particles has a momentum of 0. Which of these statements is true about the kinetic energy of the system? Not enough information. The reason is I can have two cases. That is that the velocity of all my particles is equal to 0. The other situation is I can have particles going in this direction and particles in that direction, and that still gives me a momentum equal to 0, because it is a vector quantity. All right, and they cancel out. So you have to have more information to know what the energy is. Bouncy rubber ball and a beanbag to the same mass fall to the floor from the same height. That means that they're both going to have the same velocity since they're falling from the same height. Which of these statements is true about the force imparted to the floor? The rubber ball goes down, hits the floor, and bounces back up again. The beanbag goes down, hits the floor, and stays right where it is. Because it doesn't bounce, it has less of a change in momentum. And since the change in momentum is related to the force by this, we can say that it has a greater force. So the rubber ball has a greater force because it bounces. It imparts a greater change in momentum. All right, tire placed on a balancing machine turns through 10 radians in 2 seconds. We want to know what is omega. We know that omega naught equals 0 because it starts from rest. Okay, I need to first find alpha because I don't know what alpha is. And then I want to know omega. Remember, omega is omega naught plus alpha t. That's equal to 0 plus alpha t. But I don't know what alpha is, so I need to find alpha. I can say theta equals omega naught t plus 1/2 alpha t squared. This is 0, so theta, which is 10, is equal to 1/2 alpha times 2 squared. So alpha equals 10 over 2, which is 5 radians per second squared. And then over here I can find omega. It's 5 times my time, which is 2 seconds. That's 10 radians per second. That's B for number 12. Kaiser sits on the outer rim of a merry-go-round. Chad sits midway. His linear velocity is half that of Kaiser's. Remember that V equals omega R. They have the same omega because it's a rigid body. Since the radius is half that for Chad, then the velocity is also half. So the answer for 13 is B. Ball tied to a string is being whirled about in a circle. What can you say about the force of tension on the ball? All right. I'd like to draw a picture. I have this. It's following a circular path. The tension provides the centripetal force, and so the tension always points in that direction. It is not tangent to the circular path. It does act towards the center of the path. It does not act away from the center of the path, and it's not none of these. So the answer for 14 is B. Grindstone spinning at a rate of 8.3 revolutions per second is what in radians per second? Simple conversion. 1 revolution is 2 pi radians. 8.3 times 2 pi. I get 52. So that's C. For number 15. 52 radians per second. Notice that my units here, revolutions go away. This is implied radians. I get radians per second. The car rounds a curve on a flat road. Just like this. My car from above gives the coefficient of static friction. Radius of the curve is 50 meters. I want to know what is the maximum safe speed. All right. I have to recognize that the frictional force is the same as the centripetal force. So I get mu times the normal force equals mv squared over r. This is mu s. It's static friction that's at play. The normal force is equal to the weight, mu s mg equals mv squared over r. The normal force equals the weight because this is not a banked curve. It's a flat road surface. The masses cancel. I'm looking for v. So square root of mu gr. It's 19 meters per second. That is A for 16. Object begins at rest, begins to rotate with constant angular acceleration. It rotates to a certain angle at theta and time t. One angle does it rotate in half that time. So I know the relationship between theta and t is given by this. This is made easier because this is 0, so I can just say theta equals 1/2 alpha t squared. Alright, it goes through theta in time t, but what if I have half t? That means I'm going to have a quarter theta. So the answer is C for number 17. Alright, this shows a figure, configuration of particles rotate about this vertical axis. What is the moment of inertia for this configuration? These are discrete particles, so I say I is the sum of mr squared. Alright, so that's going to be this mass, which is 2 kilograms, times 1 meter squared, plus 2 kilograms, times 1 meter squared, plus 3 kilograms times 2 meters squared. Alright, that's 1, 2, 3 particles. That's 2 plus 2 plus 3 times 4 is 12. 12 plus 4 is 16. So the answer is B for number 18. This figure shows 4 identical L-shaped objects. Each rotates about an axis as drawn. Rank the 4 from greatest to least. And as I said in class, this distance was equal to this distance, and this distance was equal to this distance. These are two identical bars that are brought together. First, I want to look at the one that has the most mass at the greatest radii, and that would be C. So C is going to have the biggest moment of inertia. All right, that gets rid of that one and that one. And then I want to find the next one. Should be obvious to you that this is the next one, because for A and B, they both have a lot of mass along the rotation axis. And in fact, A and B are identical situations. They're just rotated on the side. So the answer is C. That C has a bigger moment of inertia than D. D has a bigger moment of inertia than A, and A and B are equal. Potter's wheel is spinning at 3 revolutions per second. There's its moment of inertia, radius 0.5 meters. You throw a lump of clay on the edge of the wheel, and what is the new speed of the wheel? So we say Li equals Lf. This is angular momentum. I initial times omega initial equals I final times omega final. I initial is given, it's 0.1 kilogram meter squared, rotating at 3 revolutions per second, equals my final moment of inertia is going to equal 0.1 plus mr squared, where that is the mass of the lump of clay times the radius squared. So it's 0.1 plus 1 kilogram times 0.5 meters squared. It's 0.35. It's 0.35 omega f. If we solve for omega f, let's see, that's 0.3 over 0.35, which is 0.9 revolutions per second. Alright, so that is A for number 20. Which of these are the basic SI units for moment of inertia? We just did that. It's kilogram meter squared. C, mr squared, mass times radius squared. Disk with this mass and that radius is spinning at this speed. What is the energy of the hoop? Kinetic energy is 1/2 I omega squared. That's 1/2 I is for a cylinder. It's 1/2 mr squared. 0.5 kilograms times 1 meter squared. So a half of a half is 0.25, a quarter. So 1/2, 0.25 kilogram meter squared, times omega squared, which is 10 radians per second. That's 1/8 of 100. Is that 13? Yeah, 13. That's A. What is the net torque acting on this rod about this point right here? Alright, this provides no torque. That provides no torque. So my torque is just going to be this force times that moment arm. Fr, 25 newtons times 2 meters equals 50 Newton meters. Alright, this force causes rotation in that direction, that's clockwise. It's clockwise. Or you could represent it as a negative, but the answer here is A. This rod has a mass of 0.75 kilograms of 2 seconds while the torque acts on the rod. What is the angular velocity? So I want to know omega, which is going to be equal to alpha times t. So I need to find alpha, which is torque over I. And I, this is for a rod, a thin rod, 1/12 mb squared. So that's 1/12 of m, which is 0.75, times b, which was 4 meters squared. And I think that's 1. Let me see. Yeah, that's equal to 1 kilogram meter squared. That's my moment of inertia. So now I can find my alpha is going to be 50 Newton meters. That's from the previous problem, over 1 kilogram meter squared. So that's 50 radians per second squared. And now I can find my omega, which is going to be 50 times the number of seconds, which is 2. It's 100 radians per second, which is B. For number 24, two spheres have the same mass. One sphere is made of aluminum, other sphere is made of gold. The aluminum sphere, because it's less dense, is a lot bigger. The gold sphere, on the other hand, is a lot smaller. Remember, moment of inertia is mr squared. And so the one with the bigger radius having the same mass, the one with the bigger radius is going to have the greater moments of inertia. So the answer for number 25 is A. That's the end for exam 3.